Welcome back to our system design series. Today we are going to discuss serverless architecture. This is a modern approach to software development, has revolutionized how we build and deploy applications by allowing developers to focus purely on writing code, while the underlying infrastructure is automatically managed by the cloud provider. So let's just dive into it and let's know what makes serverless architecture unique and why it's becoming increasingly popular. I don't know if you know about serverless architecture and you know how AWS works, for example, and Lambda and all that stuff. But let's just try to answer the question about what basically is a serverless architecture, and let's just make a small example of a system that uses microservice architecture, serverless architecture, and yeah, let's try to answer some questions. So, serverless architecture abstracts away the underlying infrastructure, allowing developers to focus solely on writing code. In serverless model, the cloud provider handles all aspects of infrastructure management, including scaling, server maintenance, and resource allocation. This means that developers don't need to worry about managing servers or scaling their applications. They simply deploy their code and the cloud provider takes care of the rest. Okay, let's try to understand how it works. Let's make a quite a small example and then we can understand how it works. So let's assume that we have a client. And we said before, developers only care about just creating code. And we assume creating code it will be by basically creating functions. So let's say I have function 1 and function 2 and function 3. So as we said before, the developers only have to care about creating functions, but how the client will be able to call these functions. Basically, we have what we call API gateway. And this API gateway will call the functions for this client, and it's basically that's it. It's a pretty simple thing. Okay, so let's try to understand how it works. So in serverless setup, developers deploy functions that are triggered by events. These functions are a small piece of code designed to perform specific tasks, and they run in response to various triggers, such as HTTP request, file uploads, database changes, or schedule tasks. This event-driven model makes serverless architecture ideal for applications that need to respond quickly to specific events. Okay, let's understand some key statistics about serverless to understand some benefits of it. The first thing, we have what we call automatic scaling, because the cloud provider automatically scales the functions. Each function, the cloud will automatically scale it based on demand. If more requests come in, more instances of the functions are created, and if demand drops, the number of instances is reduced. The second thing, there is pay as you go. With serverless, you are billed only for the compute time consumed. This means you pay only when your code is running, which can lead to significant cost saving for applications with various workloads. And number three, we have no server management. Like, developers don't need to manage or provision servers. The cloud providers takes care of all infrastructure management, which allows teams to focus entirely on building features. What are the benefits of that? What is the benefits of using this type of architecture? I would say the first thing, it will be reduced operation overhead, because since the cloud provider handles all the infrastructure related tasks, developers can only focus slowly on writing and deploying code, which speeds up development and reduces operational burden. Number two, we have automatic scaling, because serverless functions scale automatically based on demand, ensuring that your application can handle spikes in traffic without manual intervention or provisioning additional sources. And also there is cost efficiency, because with a pay per execution pricing model, serverless architecture is cost effective, especially for applications with variable or unpredictable workloads. You are charged only for the actual compute time, making it a great choice for applications that don't run constantly. Okay, it looks like it's a pretty decent architecture, but does it have like a specific problem? Does it have a drawbacks? Yes, of course it has drawbacks. And one of the drawbacks, something we called a cold start. What is that? Okay, so let's just type it first. Okay, one of the most common challenges with serverless architecture is cold start. When function is not in use for a while, it may take longer to initialize the first time it's triggered, leading to increased latency. Also, there is a limited execution time, because serverless functions typically have a maximum execution time, making them unsuitable for long-running tasks. If your application requires long processing time, serverless may not be the best option. Also, there is vendor lock-in. Serverless solutions are tightly integrated with cloud providers, which can lead to vendor lock-in. Migration to another provider may require significant changes to your code base, and this is really like a nightmare. Okay, so use cases for microservice architecture. I guess you can use it in event-driven applications. You can use it in APIs and microservices. Also, it's great in real-time data processing. Um, and in your system design interview, I guess you might find that if you have any event-driven application, it's a pretty good idea to use like a serverless application. Also, you have to discuss that with your interviewer, and also to talk about the drawbacks, specifically about the vendor lock-in and the limited time execution and the cold start. You have to talk about them so that your interviewer know what you're talking about. So yeah, that's it for this video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you never miss any video, and see you guys in future problem.